Good. A little more excitement. Come on. Are you guys ready to get started? I know you just had lunch. No food comas. No falling asleep in this session. All right. So look, I like to treat my sessions as kind of like user groups, right? That's just, if you have a question, free conversation. Let's have some fun. Okay. All right. So make sure you're in the right session. We're going to talk big data for the SQL Ninja. I'll explain why I named it that in a little bit. First, if you have any questions about, yes, I look just like that. If you have any questions about what I'm going to talk about today, want my scripts, want my samples, things like that, email me. I'm happy to send them to you. Okay? So take a picture if you want. I'll put it up at the end. They'll be available at on the Ignite site. All right. Why are you here? Not at Ignite. Why are you in this session? Spent the last probably, if you've been paying attention for the last, let's say 12, 24 months, 36 months, one of the big pushes around not just Microsoft, but around, where things are going has been big data, and following that up really quick is, the Internet of Things, right? And what does this mean, right? So if you talk about big data, what is big data? And big data is, I think, so convoluted. Internet of Things is very convoluted. Everybody has their definition of what this is. But if you really boil it down to, we're SQL people, or SQL person. We, if you think about, what this means, I'm assuming you're at the session because you're SQL people, most of you, right? So, for the longest time, up until like a few years ago, we've always dealt with databases, relational databases, roles, tables, roles, columns, primary keys, foreign keys, relationships. We've always thought in terms of, of relational. And I'll talk about this toward the end a little bit, but, as we push toward big data and IoT, what does this mean, right? Where's the role of the DBA going? Right. So, if there's a problem, if the application's slow, who does everybody blame? The DBA, right? Everybody blames the data. It's the database, right? It's always the database. Okay. So at some point, I spent the last year thinking about, where are things going? Okay. Where are things going in terms of not just relational anymore? Okay. So I'm assuming you're here because, look, I'm going to make a pretty bold statement. You either get on the bandwagon with this big data stuff or get left behind, right? Plain and simple, right? And I'm not talking just cloud stuff. I'm talking just regular big data, okay? Things are, it's not just relational anymore. So either figure it out, get on the bandwagon, or be stuck in your cube doing what you're doing every day, right? But if you want to advance your career, get on with it and start figuring this stuff out, right? But I'm assuming you're here because you want to learn about these big data technologies. And there's a ton, so, we only have 60 minutes, actually 57 minutes. But I think more importantly, where's the role of the DBA going? DBA stands for Database Administrator, right? But if we're not dealing with just databases anymore, where's the role of DBA going? Right? Is it even called a DBA in the future? Right? Is it called a data steward? Who knows? I'm not coining phrases, but where's it going? Because at some point, who owns the data in any environment? The DBA, right? Theoretically, right? This guy laughs, right? But who's responsible for the data? The DBA, right? If something happens to the data, who do they blame? Who do they point fingers at, right? So again, it's just not relational anymore. So as a DBA, at some point, this big data, IoT data, is going to touch you somehow, right? At some point, somehow. So whether you either start learning about this stuff now or get left behind, right? So how, as a DBA or a data steward or whatever you want to call it, how do you start thinking about this? I've had a lot of conversations with the people back in Redmond going, how do we start thinking about this stuff, okay? And this is just, I sat down and I put this together and we had meetings to discuss, what are our thoughts? And I still don't think we've put our thumb on it because things change so fast. But the purpose of this is just to say, look, how do we get started thinking about these things that are outside of our relational world, this data that's outside of our relational world? How do we start thinking about that as a data person, right? It's going to affect us. And the other reason for this talk is to go, look, it's not that scary. right? It's actually pretty awesome, okay? I would love to use technologies that I already know to be able to work with non-relational data. Guess what? You can, right? And that's what we're going to talk about, okay? But if you really boil down to, if you look at Microsoft's data platform, right, it becomes kind of, you're like, holy crap, that's a lot, right? So you got things that boil down to how do we capture and manage data? So SQL Server, Azure SQL Database, structured and unstructured data. How do we capture and store this data? Azure HDN, so there's our big data capabilities, data lake, right? Azure Data Warehouse. So Microsoft keeps throwing these technologies at us, and oh my goodness, what do they mean, right? So but we break it down to how do we capture and manage? How do we transform and analyze that data, right? So again, it's just not relational, so we got to bring data in. So we've got Azure Machine Learning. How do we get predictive analytics on this data, real time or near real time? How do we stream this data in through Stream Analytics or Storm or things like that? We've got the Azure Data Catalog. And then once we store our data and once we transform and analyze our data, then how do we visualize this data, right? So things like Power BI and Data Zen and SQL reporting services and all that great stuff, right? So you start looking at this as a whole, you're like, that's a lot, right? But if you really boil it down, right, it's really not that bad. We're not going to talk about all of these, obviously, but we are going to talk a few of these that really have an impact on how we, as SQL people, we SQL ninjas, how do we think about this, okay? So let's have a little fun first, right? Has anybody thought about, the V's? This has been going around, so you may out of this. When we talk about big data, it's all about the V's. Anybody know what the V's are? Nope, close. It does start with a V, so very good. Yep, velocity's one. Volume. This guy does. And what's the other one? Variety, right? And you should probably add, we'll take variable. We'll accept that. Because there's this, right? Because it does start with a V, so. All right, volume, right? We'll throw some slides up about volume. But you think about, and I've got some slides on how we think about volume, right? So volume's one, just the mass amounts of data, right? Variety is, again, got to understand, it's just not relational anymore, right? You've got sensors, devices, phones, weblogs, whatever out there, and it's not in a relational form. And this is going to touch you, SQL people, at some point, right? So how do you start working with this data? And then velocity, right? Velocity is an important one because this is how fast do we need to bring in the data, but more importantly, how fast do we need to understand that data? Is it real time or is it not, near real time? How fast can that data, once we bring it in, how fast can that data sit there before we need to start, processing or understanding that data, right? So velocity is is really important, okay? About how we, how fast we need to start making business decisions on that data, okay? All right, let's have a little fun. Got kilobytes, megabytes, gigabytes, terabytes. What's after terabytes? Petabytes. What's after petabytes? Yep. What's after exabytes? All right. What's after zettabytes? Think Star Wars. Okay, so fun fact: how much data does a DVD hold? Huh? Yeah, 4.7 gig. That's what I was going after. I didn't want to get too technical. 4.7 gig. All right. It takes 250 trillion DVDs to equal 1 yottabyte. Okay. That's a lot of data. And the fact that we're already talking about yottabytes today, okay, astronomical, right? The fact that we're talking about managing that kind of amount of data, that's big data, right? And the fact that we're talking about it already, okay? Now, this is the approved scientific standard, whatever approved, right? But they're already talking about 2 more because we're already reaching the yottabyte spectrum. So they're already thinking down the road about how do we go beyond yottabytes. So there was a professor or a data scientist at Intel that came up with the next ones, right? Anybody know what they are? Okay, I don't have them on the slide. The first one is brontobytes, right? So add 3 zeros to the end of that, brontobytes, right? And the next one after that is geobytes. So add another 3 zeros, okay? So it's like 10 to the billionth what degree or something like that, some outrageous number. So the fact that they're already talking about that amount of data, right, just is astronomical, right? So this gives you a clue of what big data means, right? So let's have a little more fun, right? This was taken 4 years ago, and I tried to find an updated slide of this, but 4 years ago, they said by this year, 2015, we would have about 8 zettabytes. This is why we went through that exercise about zettabytes, right? 8 zettabytes of data, okay? If I were to be a betting man, I would bet that that number is low today, right? There's probably more than that, right? You agree? Probably low, okay? Put it in perspective a little more, right? Bing itself, not Google. Google's probably got a higher number, but Bing itself ingests over 7 petabytes of data a month. A month, petabytes, right? That's the search queries you type in. That's the results you get back, and all the metadata associated with that, right? 7 petabytes of data a month, right? So how do we track all that data? How do we know where the users came from, you know, the sentiment, things like that, right? How do we track that? And then Twitter, oh my goodness, Twitter itself generates over 1 terabyte of tweets a day, right? That's 30 terabytes a month, okay? That's a lot of data, okay? Now, just one more fun slide, and then we'll get into the meat of things, right? This is just some interesting facts I found on the web, right? 72 hours of video are uploaded per minute on YouTube. That's 1 terabyte every 4 minutes, okay? 500 terabytes of new data per day are ingested in Facebook. I am not one of those. I am not on Facebook, nor will I ever be. Sensors from a Boeing jet engine create 20 terabytes of data an hour, and they're proposing to create this massive telescope, and I can't remember where they're going to put it, but this telescope, it's called the Square Kilometer Array Telescope. It'll search 1 square kilometer out so far out further than anybody's ever seen before, and the data that telescope will create is a few exabytes of data per day, single beam, right? So this is the kind of data, right? We're already at yottabytes, and we talk about right, brontobytes and geobytes, right? This kind of puts things in perspective, doesn't it? About the kind of data, type of amount of data that we're dealing with every single day. How do we start processing and analyzing this data? So we do this through things like mass processing systems, right? Hadoop people? Nobody? That is a first. I am writing this down, right? First, so Hadoop, right? Hadoop is a mass data processing system, right? Think about it, and if I need to process, and we'll go into detail about this in a second, right? But this is, if you think about Hadoop is the ability to say, I'm going to process data from any type, any structured or non-structured type, right? Could be text files, could be stream data, whatever, sensor data, device, it doesn't matter, okay? And if I've got just exabytes of data, terabytes, petabytes, whatever of data, how do I process that? Today we think in SQL Server, it's okay, we got one box, right? We're going to start churning on this data. What Hadoop says is that I'm going to take all this data and distribute that data across multiple, many nodes, hundreds of nodes if necessary, right? This is Hadoop, right? It's Apache Hadoop. We've heard of Hortonworks and Cloudera and things like that. This is Hadoop, Apache Hadoop, right? But if you start looking at this, all these technologies around, how do I start working with all these different, Hadoop and all these different data sources and file types and different data types and things like that, it becomes kind of, again, overwhelming a little bit, right? Because I can PowerShell, C#, I've got APIs and Polybase over there. Got the distributed storage, so we're thinking about scripting pig, all these different things. Like, oh my goodness, how do I, I'm telling you to get on the bandwagon or get left behind, but then I show you this slide, and you're like, I'm not even getting started on that, right? Kind of cumbersome. But if we really look at this and boil this down to what we really need to know is this, right? It really kind of boils this down to, look, Hadoop, the architecture is simple. I've got this mass distributed file system that sits on HDFS, the Hadoop distributed file system, okay? This is what scales out, right? We're not going to go, this is not a class on Hadoop, so we're not going to go into the architecture of that. But on top of that, I've got tools that allow me to deal with these kind of data, right? So I can use Pig for, ETL processing type of workloads. I can use HiveQL for, writing kind of T-SQL-like or SQL-like syntax on top of that for BI reporting. And Scoop. Scoop is an interesting one because what if I need to move data from a non-relational to a relational database and back and forth, right? Again, I've got data coming in from all sorts of sources. It's going to affect me. How do I get data if I need to in a relational database? Great, I can use Scoop, right? And so what we're going to talk about today is all these tools, to work with all these tools that in technologies and languages that you already know, right? because again, it's not that scary, okay? So let's talk about HD Insight a little more. So HD Insight is very simple, okay? In an on-premise environment, we all understand on-premises, right? If I need to scale on-premises, I start adding machines. Hadoop's the same way, right? If I need to start scaling, and then to start scaling from like 10 nodes to hundreds of nodes, I got to start adding hardware, right? HD Insight is Microsoft's cloud platform that takes basically Hadoop and that allows me to scale automatically, right? I don't have to pre-buy hardware. If I want to scale, I can just move my slider from 5 nodes, move that slider to 100 nodes. Within minutes, I've got 100 nodes, right? And I always pay for those resources that I use, okay? We just basically took Apache Hadoop and said, we're going to make this run as a service, right? This is, HD Insight is Hadoop as a service, right? It's as simple as that, okay? We just took Hortonworks. But let's take a step back and think about this in terms of, we understand relational. So how does this work with, and how does this compare to, how does Hadoop compare to a relational database, okay? So on the left, we have our relational database system. On the right, we have Hadoop. We need to understand, if we're SQL people, we understand that, that we understand how SQL works. Hadoop does not work that way, right? And we need to understand that, right? RDBMS is, SQL Server, this works with, we can do terabytes. We see systems with terabytes and larger systems, right? We get that. It's a great platform. Hadoop is for much more than that. Hadoop says, because we're not crunching in a relational database, we're basically processing, distributing data across many nodes. So it can process, yottabytes of data much easier because I'm distributing that data across however many nodes I want to, right? Or, hundreds of nodes or thousands if I need to, right? SQL is an OLTP system, right? This is a high transactional system. It's read, write, update many times, okay? Hadoop is not that. Hadoop is a write once, read many times. If you're writing, if you're treating Hadoop as a transactional database, you're doing it wrong, way wrong, right? Hadoop is not a transactional database. It is a write once, but let me process that data. Let me get insights into my data, that real-time, almost real-time processing, right? We scale SQL Server by, either throwing hardware at, throwing more memory and CPU at it, right? Hadoop we scale by adding more nodes, okay? This is, it's a linear scale, okay? Schema, we're going to see schema in a minute because schema is, in a SQL Server, it's a static schema. It's create table, there it is, okay? When we create a table in Hadoop /HD Insight, this is not a disk-based table, okay, because the schema gets applied when we read. So it's more of a metadata to basically tell us what's the structure and how we want our data returned, okay, things like that. All right? Okay, so if you go back a couple slides, here's what, I want to point out the Hadoop distributed file system, right? Every Hadoop node has this Hadoop distributed file system. This is where, when we start processing our data, this is where our data resides, right? This is where Hadoop starts pulling data from to process it. So when we get into HD Insight and we say, what is HD Insight? We have two options for storing our data. We have the Hadoop distributed file system, because again, HD Insight is Hadoop as a service, so we do have access to the HDFS. But we even have a better storage option, which is called Azure Storage. Anybody familiar with Azure Storage? Right? This is the ability to say, I can store a ton of data for very cheap, right? Now, in Azure, again, Azure's not free, so when we create our HD Insight cluster, right, we don't want to leave that, because it's not like we're running things every day, right? So if we're spinning up a 100-node HD Insight cluster, Hadoop cluster, it's just spinning up VMs behind the scene, all right? If we leave that running for a month, get out your checkbook because you're going to be writing a very expensive check to Microsoft, right? So best practice states that you can tear this stuff up and down as you need it within a matter of minutes. The problem is if we tear down our HD Insight cluster, where does our HDFS go? We lose that, right? So we have the ability through Azure to say, I'm going to store my data in Azure Blob Storage, and that way if I tear down my cluster because I don't need it, I still have my data, right? Much better option, okay? So with that, let me jump out and let me show you how this is done. Let's see. Am I that one? I'm that one, okay. All right, so there's two ways you can do this, and I'm going to show you both, right? Okay. So there's several ways we can do this. PowerShell people in the room? That's it? Come on, people. PowerShell's awesome. All right. So I'm going to show you the PowerShell way to go first, right? And so this is how I created my cluster. So here's what I'm creating my HD Insight cluster. Whoops. Okay. So to create your cluster in PowerShell, can you guys see that all right? Okay. I can zoom in a little bit if we need to. But it's simple as that, right? I just define a couple of variables, right? So what's my storage account name? Again, where am I pulling my data from if I'm going to store my data in Azure Storage? What's my cluster name? What's my username and password? Where, what Azure Data Center am I putting in? And how many cluster nodes, how many data nodes do I want in my cluster, right? And then I simply say create cluster. Simple as that, right? So within a few lines of code, I've created my HD Insight cluster, right? And to tear it down is, I think, 2 lines of PowerShell code, right? Delete cluster, done, okay? But simple as that. But let me show you how to do this through the Azure portal, because this is going to make a little more sense, right? So I'm going to go here. I'm going to say, let's create an HD Insight cluster. I'm going to say new data services. I'm going to say custom create. Now I can say Hadoop cluster because that's what it is. And if I click Hadoop cluster, all I get is the ability to say what's the cluster name, how many data nodes, what's my username and password, right? But I need to specify a little more information than that because for certain reasons, we'll explain that. So I say custom create, okay? So I'm going to give it a cluster name. We're going to call this Ignite New Zealand cluster, right? I want Hadoop. Right? I can also do a HBase. We're going to talk about HBase at the latter end of this presentation. I've also created a Storm and Spark cluster. Right? We won't get into those. I'm going to do an Hadoop cluster. What operating system do I want to run this on? Apache Hadoop is Apache, so typically, by default, runs on Linux. But we ported it to run on Windows. So either one, you can run it on Linux or Windows. We're going to run it on Windows just for grins. And what version of Hadoop do I want to run? Well, I'm going to run the latest and greatest because I like living on the bleeding edge. And then how many data nodes do I want? Now this is important, right? Whenever you create an Azure subscription, you are allotted X number of cores, CPU cores, right? So anytime you create this, you have to do the math. So every data node has 4 cores, right? And then you have on top of that your head node, and the head node is also 4 cores, okay? So if I create a 4-node cluster, and with my head node, so 4 times 5 is 20. So this is going to take 20 cores out of my cluster allotment. Okay, just keep that in mind. So I'm going to say, just for grins, I'm going to say 2 cores. I'm going to put this in available for the subscription. All right, so I'm going to say, I can't do 1. Yep, so I'm going to say 1, put this in West US. And what's the head node and data node size? Again, right, so how many cores am I taking? So I'm going to just say, just for giggles, I'm going to say, I can only go 4 cores, right? So we'll say 4 cores for both. And then what's my HTTP username? This is kind of important, right? So I'm going to give it an HTTP username. Give it a password for both. They should be the same. And then again, remember I can either store data in my HDFS or my storage account. I'm going to say, look, I want to store data in my storage account. What storage account do I want to put it in? I'm going to say an existing storage account. I want my West US storage account. Do I want any other containers? I want to put my in containers simply like, think of it like Windows Explorer folders and hierarchy, things like that. All right, so I'm going to put this in HDI storage. And then I can say next. I'm not going to click next, right? But at this point, what it does is it's spinning up an Hadoop cluster, a 1-node Hadoop cluster behind the scenes. It also just spinning up VMs behind the scene, right? Simple as that, okay? So now I have my Hadoop cluster, and I've already got some going. Here's my 2-node HD Insight cluster right there. Look at that. There's my dashboard. The dashboard says, hey, what's going on? It's taking 24 cores out of my 60-core allotment. Here's any linked resources of my storage account. But I can look at the activity, what's going on, activity inside my HD Insight cluster, right? I can configure this and say, well, I want to turn off Hadoop services. I can scale this and say, hey, I want to add. So this is how easy it is to scale your Hadoop cluster. This is the beauty of Azure. If I need more processing power, move the slider. That's it. Move the slider. We can't make it any easier, right? Move the slider, right? Then when I'm done, I can move that slider back down and just, that's how easy it is, all right? So quick demo on creating an HD Insight cluster, okay? But we're not going to stop there, okay? So let's keep going a little bit, right? So now that we've created our cluster, now what, right? Again, any questions about about what Hadoop is, right? Because this is the basis of our entire presentation, right? Mass data processing, right? Doesn't matter the data type. Mass data processing, okay? Across many, many, many thousands of nodes if we need to, right? So if my slider would go up to, 10,000 nodes, I can move my slider up to 10,000 nodes if I need to, right? Okay, but now that we've created our cluster, now what? How do we start working with this data? Because we've got our cluster, the cluster is important. How do we start working with this data, okay? So if you know PowerShell, boom, spin it up in about 10 lines of code. If you like GUI, spin it up, in a matter of seconds using the GUI, right? I've got our HCI Insight cluster. But now we need to start working with that data, and you've got several options to start working with that data. I can use .NET, I can use Java, Hive. We'll talk about Hive next. We'll talk Scoop. Scoop, I want to move data between relational and non-relational. We'll talk about Scoop in a second. Pig, I don't know who named these, right? Because you got Shark. Right? If you want to stream data, you got Storm and Stream Analytics. You want to visualize that data, you've got Excel, right? So this is, and there's others as well, right? But I want to start, how do I start querying this data? How do I start working with this data that's sitting in Hadoop or blob storage through Hadoop, right? How do I start doing that? All right, well, we can use Hive, right? Remember, Hive is what? Hive was a kind of HiveQL. Remember that? A SQL-like syntax to query non-relational data, right? SQL people, who can write SQL queries? Almost every hand should go up, right? Well, then you can use this too. Awesome, right? So it's a data warehousing for SQL-like syntax to be able to query any type of data. Relational, non-relational, doesn't matter, right? So you can see an example there, okay? Integration between Hoop and BI and visualization tools. I can actually open Excel, use Excel to connect to my HD Insight cluster and write T-SQL syntax to pull data from a non-relational store. Ta-da, right? Awesome, because I can write SQL, I can pull data. Okay, done. Let's look at an example. Okay, all right. So what I have here is we looked at my HD Insight cluster. I went into my HD Insight cluster, and if I go over to configure, I don't even have to do that. I can go to this node down here, Query Console. You guys see that? Query Console. When I open that, I get this. Okay, that opens this. And when you open that, when you click on Query Console, it asks you to log in with that new username and password. Okay, that's why I go through the custom create, because it allows me to enter that username and password to be able to log into here. Okay, and here I have things that I can start playing with. Right, I've got some getting started gallery. How do I start learning about Azure, analytics and things like that, and solutions for working with data. But what we're going to do is we're going to look at the Hive editor. Okay, here's our Hive editor. And our Hive editor is simply, I want to start writing SQL syntax queries to get to data, right? So I have out here, sitting out here in HCI example, I use this in a few other sessions. I've got this 11 meg file. It's got about 270,000 rows, and this is I've got this from the London Underground data, right? So anytime you call it the tube, the subway, right? You go through the styles. Anytime you check in and check out go through there, it registers this. You can download this data. It's open, right? So I went and got it abbreviated. So it had like 20 columns. I went and got this down to about 6 columns, just for demo purposes. This is the data I'm going to query, and I'm going to query this through SQL, right? This is a comma-separated file, right? And I'm going to do that by simply going in here. I'm going to go to this document. I'm going to grab this, okay? Now, let's go back to my portal. Do that. We'll call this test 1. If I can type test 1. Okay. Now you notice that any jobs that I've run, I would submit here. But look at this. Does this not look very? It's not exactly T-SQL, but does this not look very similar to SQL? Right. So if you can write T-SQL, you should be able to write this. Right. So drop table station usage. This table doesn't exist anymore, so I can get rid of that. Right. But I've got create table. The only difference is I don't need these. This line says, let me walk you through these lines, right? Create table, external table. Let me explain what external says. Table station usage, and I have the column name and the data type, right? So string. It doesn't say string 50 characters. It doesn't say date times 7 or things like that. It's simply string. You say date, int, big int, things like that, right? So very similar to T-SQL. So I've basically defined my table structure right there. Okay, int, right? Then I say, and what I have to do, tell it, because it's basically a table, because I'm reading data that's not relational, could come from wherever, I have to say, look, this is not coming from relational data. It's really coming from a comma separated file. So that third line there says, row format delimited by, this is a comma separated file. That's all I'm telling it in the second line. The third line says, go get the data from here, right? So I'm saying stored as text file location. There's a location of the data I want you to go get the data from, okay? Now, table properties, I'm not going to use that. That just says, hey, skip the first two lines because maybe the first line has the column names in it, right? Something like that. So I'm going to go get rid of those, right? And then standard T-SQL, select column, 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 column from table, okay? So if you can't do this, find another job, okay? This is, I am using T-SQL or SQL-like syntax to go query a non-relational store, right? So let's go execute that. Did I spell test right? Doesn't matter. We're going to execute that. And what it's doing behind the scenes, again, we're not going to get into the bowels of what Hadoop and everything does behind the scenes, but really this is doing just a simple map reduce job behind the scenes, okay? We won't get into map reduce. But it's simply going and executing map reduce, and that map reduce says, look, I have a file out here, one file, so I don't need this massive 4-node cluster. But I got this one file. If I had thousands of files out in there, it would say, let's do a map reduce job, which says, go take this. It basically takes let's call it a work order. Go get all this data, distribute all these files and all this data across all these nodes, and start processing this data. Okay? Kind of moot here because I have one file, 4 nodes, right? That's like building an aircraft carrier to go fishing, right? So this is running, but simply this is the ability to say I have terabytes and terabytes and exabytes of data out there, and I can simply write a simple SQL statement to query all that data, right? Yes. Oh yeah, okay. Thank you. I meant to go back to the external statement. Okay, so that'll be. I can talk now while this is running. All right. So external means. So when I say create in SQL Server, when I say create table, I get a physical table, right? Disk-based table. Okay. Remember when we had that architecture of Hadoop up, and we compared a relational to non-relational, Hadoop to right? It said what? So what was the schema? One was static and one was dynamic, right? So external means create a table, but it's not a disk-based table. But store let's call it the metadata, because when I say select star from, it's basically going to say go get this data and apply this schema to the data that's coming in, right? Does that make sense? And it says external means keep the data, keep the results in the source. Don't keep it.
So when it's finished, there's no table that you have to always recreate the table.
No, so it's kind of there, but it's more of a metadata. It's not a physical. What's that? Yeah, so you can think of it, I think the easiest way to describe it is think of it like a view, but it's not really a view, right? But you can, if that makes it, yeah, you can think of it as a view.
Can you go in and find
Right, so if you think about the syntax here, right? Because once this is done, I can actually run this query, show tables, and it'll say, hey, there's a table called station out there, right? But it is not a disk-based table, right? Because the other statement was, if I were to run this again, I still need to drop the table. But remember, the schema is applied on read, right? So when I say select star from table, it says, hey, I have this data out there that's non-relational. Apply the schema to it, right? So the schema is applied on read. Does that make sense? Okay, right? But I think what makes it confusing is I still have to drop it, and I can drop it. It's still there. I can do show tables, but it is not a physical like we think on SQL Server table. Okay. Because it's more of a dynamic. I think of it as a view. It's more of just a metadata structure around the data that I want to query. A dynamic. You call it a dynamic schema, right? All right. Let's go see if our job is done. Completed. All right. Woo. All right. So if we go and click on the results of it said completed. We go and click on the results of this. It opens up a new query window. There is our job, and there is our data. Right? All 200 and almost 70,000 rows of our data, right? So point is, I used SQL to query a non-relational data. Yeah, woo, yeah. Okay, any questions about that? Yes, way back in the... I'm sorry? Oh, yeah. How does it differ from the SQL 16 external? Kind of the same concept, right? This is Hadoop, but an external table, really, when you do it in SQL Server 2016, it's very much the same concept, right? It's just applying, it's a dynamic table that applies the structure on read, right? Same concept.
What if the data doesn't actually match the financial?
I get that question every time. Every time. You'll get an error. It'll just say, hey, I can't do this, right? So this is, again, this is not, if I had out here thousands of files, right, in order to get this to work in the right way, every file would need to have the same structure, right? So your homework assignment, when you start working with this is, how do I start, I've got this, because I can have multiple folders, multiple jobs. So it's like, okay, how do I start organizing my data? Because I have data coming in this format. I have data coming in this format. I have data coming in this format. So I may have to structure my storage to say, okay, I'm going to store this data here, this data here, this data here, right? So it only makes sense to say, okay, if I've got thousands and thousands and thousands of files, I'm going to put all the files that have the same schema in the same location, because then I don't have to execute one. Otherwise, if there's one that doesn't match and it starts processing this, it's going to go, and barf all over itself. Okay. It's like different tables from the same. Oh, no. So you can't say, I don't know of a way to go, okay, process this file and then skip 10 and process this file and, right? It's going to process everything. If you look at the syntax, where's the syntax? Right? It says, look, just process everything in that directory. Right? So whatever's in that directory, right? So remember, this is my storage account. HDI example right here, that is this container, HDI example. Okay, so I said, go into this container, this folder, we'll call it a folder, in the storage account and process everything that's in there. Right? So it has, so essentially it has to match that schema. Right? And it's going to do everything in that directory. Okay? Okay, but the point is, and hopefully I'm getting this across, the point is, I just wrote T-SQL, SQL-like, to query a CSV file, right? So the beauty of this is that I can use this to query any other type of data. It doesn't matter where it's coming from. Okay, as long as I know the structure, done, right? Okay, make sense? All right, let's move on, because we got 22 minutes left. All right. Okay, so we talked about, now that we've got our data, and our data is sitting in, could be in HDFS, or could be in Azure Blob Storage, you might be saying, well, how do I move data? I've got this data coming in, and I may want to get that data, or I have data in a relational database, and I need to get that into Hadoop, or a non-structured store. Or I got data in an unstructured store. How do I get data in that unstructured store into my relational database? And this is what Scoop is, right? Scoop simply says it is a command line interface, no UI yet, but a command line interface that simply allows me to move data from a non-relational store and a relational store, or vice versa, right? Simple as that, right? And if you know PowerShell, this is your best friend, okay? So let's do a Scoop demo, okay? So go out here. I have Scoop, edit. And here's my Scoop, right? And again, it's almost the same thing, if you guys can see that, all right? Okay, let's zoom in just a little bit. Okay, so here I have the same thing. I'm just defining, the only difference here is I'm still defining my storage account, my cluster name, because that's where I'm going to get the data. So there's my cluster name, there's the data where I'm going to go get the, the folder container where I'm going to go get the data. Now, I can do two things. I can say if I want to connect to Azure SQL Database, or if I want to connect to on-premise SQL Server, there's the two connection strings. In this demo, I'm connecting to my Azure SQL Database. So there's the, and I will be changing this since this is being recorded. I'll be changing my password. All right, but there's all the connection information for my Azure SQL Database. In fact, there's the database name and the table name that I want to move. And then, so I connect. There's the directory, and then go create a job definition, and then go, right? So really, 1, 2, 3. about 3 or 4 lines just to actually do the stuff. Most of it is defining the variables to go execute, right? That's it. So if you know PowerShell and about 4 lines of code minus the, not including all the variables I'm setting, right? I've just executed a scoop command, right? And what this will do is make sure my demo's working right. So let me connect to SQL Server. I may have to change my config here. Yep, okay. Nice. Hold on a second. I'm going to go back here and add an IP address. 1 second. Okay, what is that IP address? 123.255. Is that what this says? All right, so we're going to add that. And we're going to make this just for fun. 1 to 255. Okay, add that. Now we should be able to connect again. All right, so out on my Azure SQL database, I have this database. There is you saw here, there's the HG Insight and the station, so I should have a table out here, a database called HG Insight, and in there is a table called station. Tables. Come on. Station. All right, so what I'm going to do is I'm just going to fire this off. Hopefully this will work given the internet. So there's my table, and I'm simply going to go, and so what it's going to do is it's simply going to do an export job. It's simply going to go move this data from that file, the data from there. It's not even going to use that table we created earlier. It's just going to say, look, so if you want to think about it in simple terms, it's really essentially, I hope I'm not saying this wrong, but essentially maybe like doing a BCP between source and destination, right? Essentially what it's doing, okay? So if I fire this thing off, hopefully this will work. So let's fire this off. It's going to ask me to authenticate, so I'm going to authenticate. All right, 15 minutes left. So what I'm going to do is this takes a few minutes to run, so what I'm going to do is I'm going to start this, and then we'll continue, and we'll come back to that if that's okay, because this is going to take a few minutes. Okay, hopefully that's running. Okay, we'll come back to that. Hopefully it won't error. All right, we good? We're good. It should be running. Okay, so let's come back. We'll come back to this side. All right, so we will definitely come back to that. Oh, no. Okay, so does that make sense? We'll come back to the demo because it's going to take a few minutes to run, but does this make sense? We good so far? All right, so let's talk about the next one, and we'll sort of wrap up with this HBase, okay? HBase is another one. HBase is a non-relational store. Are you guys familiar with key value pair stores? Okay, HBase is a key value pair store on top of Hadoop, right? So the question is, how do I query a key value pair store? Okay, so this is where HBase comes in. And so I alluded to this earlier, and I told you I'd come back to this. We've got to be very honest here, right? Whenever we say NoSQL, people tend to think it means no SQL, right? How many of you thought that? I'm not going to put you on the spot. How many thought that, right? We say NoSQL, people think, heaven forbid we do anything but SQL, right? But it doesn't mean that. What does it really mean? It means not only SQL. And we have to get our mindset around this not only SQL, right? Because that's why I went on this diatribe earlier about we have to understand that as DBAs, all this non-relational data is going to affect us and touch us somehow, right? Because it's not only SQL. It's not only relational anymore, right? The sooner we start playing with this stuff, the sooner we start understanding these technologies, the better all our lives will be, okay? So we get into HBase, right? HBase is a NoSQL store, much like Couch, Mongo, these are document data stores, some of them, but, right? Or things like, Azure table storage, key value pair storage, right? So there's a lot of these out there. How do we start working with these key value pair stores? And if you're thinking key value pair, I can't write a select statement against a key value pair store. Wrong, right? You can, and this is what this is what this product called Squirrel, Squirrel of all things does. Okay, so I'm going to show you. Whoops, let me show you Squirrel. Okay, so let me jump back out and show you Squirrel. Okay, and the way to do this one, let me get rid of that. Okay, good. All right, so I have out here my other my other cluster. So what I did is I actually created I can go when I say HDN side, I can create an HBase cluster, right? So again, HBase is a Hadoop-based key value pair store. Okay, I already created that VM. That is up, or that cluster. There's my HBase cluster. And what I'm going to do is I'm going to go into here. What did I just do? Oh, I'm going to connect into that VM. So there's two ways you can do this, right? Typically, in this environment, you'd have a cluster, and you'd install this, and there's documentation out on MSDN on. Let me make sure I get my password right here. Feel free to write this down. That one. Get that? Okay. Make sure we're good. Yeah, we're good. Okay. Okay. The easiest way to demo this is to essentially RDP into the head node and run this locally for demo purposes, right? But in a real-world environment, you'd have your cluster, you'd install Squirrel, you configure that to talk to your node and things like that. But for demo purposes, I RDP'd into the head node. If you want, here is all the instructions, not there, and not there. Here's all the instructions right there, steps 1 through 29 on how to get this to work just on the head node of your HBase cluster. Happy to send that to you if you want to start playing with this. Okay. Okay. And it's not that hard. All I did was go in there. You have to download the Squirrel client utility. Okay, which is this. Okay. So I did not come up with these names. Don't ask me who came up with these names. Okay, so I've got the Squirrel, and it's a two-step process, right? So you install Squirrel. When you install the HBase, it installs all the drivers. So step 1 is you go and create the driver, and the driver's out here. I called it Phoenix. This is actually called the Phoenix driver. Okay, so I created the Phoenix driver, gave it the URL and the name, and what the class name to be able to connect to Squirrel and my HBase cluster is. So once I have my I know that's hard to see. Let me do this. There you go. Right? So first thing is just create the driver. The driver allows me to talk to HBase. Okay? Simple as that. So the driver is actually called a Phoenix driver, right, to be able to talk to HBase. So I create the driver, right? And then when I'm done with that, I go create an alias. And the alias simply says, all right, configure the alias, and so it uses that driver. It says, here's the path, and here's where we're going to go talk to HBase. Here's my HBase instance. Let me go talk to that. Right? Make sense? We good so far? So let me connect. This will take 1 second to connect. Okay. There we go. And notice here I have a SQL tab. Okay. So what I'm going to do is I'm going to go and I'm going to click on this SQL tab. And I am actually going to go. So what I've done, just let's understand what we've done so far. I've created a driver, and I've created basically a source to talk to my HBase cluster, right? That's what I've done so far. So what I'm going to do now is I'm actually going to go back to my Word document, and I'm going to copy and paste this. Okay. Paste. Oops, not once. Once. Right. Move there so you can see that. Okay, can you see that? Does that not look like T-SQL? Create table if not exists. T-SQL, people. Create table if not exists. Insert into table. Values, bang, 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 bang. Select star from table, right? So if I'm dealing with, if I've got data that I'm pulling data, let's say from, doesn't matter where, sensor data, device data. Like if I want to pull Twitter data in, because Twitter data is a perfect example, right? Key value pair type of store, right? I may be pulling whatever type of data, and I'm pulling that into HBase. I now have a tool, and now have a tool and the ability to query non-relational key value pair data using T-SQL, right? Don't have to learn anything new through Squirrel. Could be dolphin for all I care, right? Okay, so let me run this and execute that. Okay, there you go. Select star from population, there you go, right? So I just wrote T-SQL to go in and create and query a non-relational store, key value pair in this example, right? Simple, right? So again, not scary. There's the tools and the ability out there to work with these data types and these different data sources in languages that we already know, right? Make sense? All right. Okay. I'm afraid to look. That's working. All right. Yep. So we should be able to go out, MapReduce. So it's doing a MapReduce job. We should be able to go out to our database, to station, and say select star from station. From station. From station. It's going to bark at me, probably. All right, let's get rid of that. All right. Come on. Don't crap on me right now. I'm doing so good. There we go. Woo! Let's execute that before it has any other. Yeah. There's our data. Okay. So we just pulled, still executing, but I don't know how, the job's not done yet. Right, it's still going, 96%, so it's almost done. So again, it's doing a MapReduce job. That MapReduce is distributing that. There's nothing to distribute in the one file, but if it had multiple files, it'd be doing the MapReduce behind the scenes, right? All right, so there's our data, right? How many rows we got? Oh, it's still executing. All right, so awesome, right? It's just a few lines of code, move data. And I could do the same thing on the flip side, because notice here what I'm doing is a export, okay? I could just as easily say, I want to go the other way. And this would do the same thing. Same syntax, just I'm doing an import. I want to go the other way, right? Ta-da, simple as that. All right, let's go back to the slides. Okay. So did HBase. All right. Now the question is, how does all of this fit together in the beginning to end flow? We talked about several of these components. Where do they really fit into the big picture, right? So let me paint this picture for you. Okay? All right. Hopefully this helps. Let me walk you through this a little bit, right? So on the left, I have my event producers, right? Again, data that's being generated from whatever it is. Could be devices, sensors, social media data, could be whatever, right? I got data coming in. That data, remember we put that slide up, we've got to the kind of overwhelming, we had the data capture and manage, we had the visualize and the transform sections, right? This is what this is, right? So there's our capture and manage. We're going to store, we can bring that and store that. We talked about Apache store, we talked about HD Insight. There's our, again, HD Insight. But we're bringing data in. We can run run events on that through Event Hub to say, hey, depending on the type of data or what do we want to do with that data? Where do we want to route that data? Azure Machine Learning says, hey, I'm bringing this data in, and in real time, I want to do predictive analytics on that data. Okay? So the things we talked about really sit in here because we're bringing the data has already been sitting in our lap in storage, right? So we got data coming in. We're going to process that data because it's already stored. We may do predictive analytics through Azure Machine Learning. We may do stream processing, or maybe do an event processing to do something else with that data, right? And then we may push this data off somewhere else. We may say, hey, we want to push this data off into DocumentDB or a relational database or some other store and do processing on it, okay? And essentially, we may do, hey, now I want to visualize this data. So let me bring up Power BI. Let me do search, Azure Search to be able to do full text search capabilities or language, wasn't real-time language. What's that? What's that? Thank you, natural language query on that data, right? So again, does this help? Right, so I've got my event producers to do something with that data. What we talked about sits right in here because the data is already in our lap. I'm going to start working with our data, start processing that data through the tools that we already know, right? Through T-SQL, through SQL-like syntax, through PowerShell and other tools, okay? If I want to take that data, maybe put that into a JSON-based document so that I can query that or store that in a JSON-based document. And then query that later on, things like that, right? And then visualize that data. So the end-to-end capture, stream, capture, store, process, send, visualize. Okay? Does that help paint the picture? Okay? Any questions? Okay. Okay. That's it. I'll give you 4 minutes back. All right. Was this helpful? Okay. Any questions? Does all make sense? Did I do that good of a job, or are you just like this? I had no idea what he was talking about. Okay. Anyway, you got 3 minutes back. Thank you for coming. I appreciate it. I'll be here the rest of the day and tomorrow and Friday.